Hi guys, this is just a quick video to explain what we are doing in class today with our equilibrium constant. So anytime you see this letter K, K represents our equilibrium constant. And basically our equilibrium constant is just a ratio of products to reactants, specifically at equilibrium. So this expression right here that we have is going to be based on our balanced chemical reaction. So this right here is the example of my balanced chemical reaction. You can see that we have reactants A, B, C, and D. When we write our equilibrium expression, we're going to put our products on the top of the fraction, and we're going to put our reactants on the bottom. And when we put our reactants on the bottom, we're also going to have exponents for each of our products and each of our reactants. Those exponents are going to be determined based on the coefficient from the balanced chemical equation. So we're going to take whatever our products are, put them on the top. We're going to put them in brackets. Remember that brackets represent molarity. And so we'll be plugging in molarity here. Sorry, I don't know what's wrong with my pen, but we'll be plugging in molarity right there for concentration. Concentration of my products, we're going to raise them to the exponent of whatever the coefficient is in front of that particular product over my reactants. And when I do that calculation, it's going to give me a ratio. That ratio is going to tell me how many products compared to reactants I have at equilibrium. And so also, it's going to be important for us to know when we actually do that calculation, if we get K values that are equal to 1, then the products and the reactants are equal to each other at equilibrium. If K is greater than 1, it means there's more products at equilibrium, or sometimes we call that being product favored. If K is less than 1, then we have more reactants at equilibrium. So let's go ahead and do a quick example. All right, here we go. So I have this reaction. I've got N2O4, and that is on my reactant side. Even though my arrow goes in both directions, we're still going to consider everything on the left side, my reactants, and everything on my right side, my products. So I've got N2O4 on my reactant side. I've got NO2 on my product side. If I want to calculate K, I first want to go ahead and write this equation by taking my products, NO2, and raising it to the exponent of whatever that coefficient is. So that coefficient is 2. So I'm going to square that concentration value. Then I'm going to take N2O4 and I'm going to, yeah, something is weird with my pen, but that's okay. We'll get through it. N2O4 goes on the bottom. There is no coefficient in front. So we don't need to put an exponent there. Okay, now I can just go ahead and plug in my numbers. So I have my concentration of NO2 is 0.03, and I'm going to square that number. And my concentration of N2O4 is 0.0045. So I'm going to go ahead and calculate that number. So 0.03 squared, and then divided by 0.0045. gives me an answer of 0.2. Now, something to remember with K values, there are actually no units here. It's one of the only numbers that we don't have to put units for because it is a ratio of how many reactants and products there are compared to each other at equilibrium. In this case, K is less than 1. So when K is less than 1, it means that there are more reactants. It's basically telling me my number on the bottom that I calculated is smaller than my number on the top, right? So there are more reactants at equilibrium, or we would call that reactant favored. Okay, so there are some practice problems. You guys, if you are absent because you were out taking the test or absent for other reasons, check Google Classroom. There's like 5 practice problems for you guys to calculate K values and figure out what is favored reactants products at equilibrium. So go ahead and get that done, and I'll see you guys in class. Have a good day.